Hello. Today, we will discuss about overband. In superconductors, the elements that reinforce the structure include coil bobbins, overband, preload force, and structure. In this session, we will examine what overband is. For information on coil bobbins and preload force and structure, you can refer to Chapter 3.3.1 and Chapter 3.3.3, respectively. First, superconductor magnets generate strong magnetic fields. As a result of this magnetic field, magnetic pressure is exerted on the magnet. Even with a magnetic field of 2.7 Tesla, it experiences pressure equivalent to being at a depth of 300 meters underwater, and with a magnetic field of 16.5 Tesla, it experiences pressure equivalent to being at the deepest part of the ocean. However, advancements are being made to generate even stronger magnetic fields in superconductor magnets. This implies that greater magnetic pressure is exerted on superconductor magnets. The image in the bottom left shows a superconductor magnet created by Professor Sung-Yong Han, capable of generating a magnetic field of 45.5 Tesla. This magnetic field exerts tremendous pressure, equivalent to 8,100 atmospheres, which is akin to being at a depth of 81,000 meters underwater. As mentioned earlier, a strong magnetic field brings about significant magnetic pressure, leading to deformation in the magnet. As the magnetic field is generated, the superconductor magnet experiences outward forces, ultimately resulting in deformation. This deformation divides into axial and radial directions, as illustrated in the bottom right diagram. Overband structure serves the purpose of limiting radial displacement. The definition of overbanding is as follows. Overbanding involves winding a stiff and tough material over the target coil. The purpose of overbanding is to reduce radial displacement, particularly reducing the radial displacement of the innermost turn where hoop stress is the greatest. The image in the bottom left shows the target coil and overband, while the graph on the right illustrates the difference between having overbanding and not having it. The blue graph represents the hoop stress and radial displacement acting on the magnet when overbanding is absent, while the black graph represents the hoop stress and radial displacement when overbanding is applied. It can be observed that when overbanding is applied, stress and displacement decrease by approximately twofold. To summarize, overbanding structures are used to limit how much a magnet moves sideways because of magnetic pressure. High-temperature superconductor magnets create extremely strong magnetic fields, resulting in pressure that's thousands of times greater than atmospheric pressure. In these magnets, movement happens both sideways and lengthwise due to this pressure. Overband structures are there to help reduce the sideways movement of the superconductor magnet. That concludes the presentation on overband. Thank you for your attention.